And we are going to do this using long division and understand the significance of the factor theorem. So with the factor theorem, we'll also be using synthetic division today. So the first thing the textbook mentions when you're doing long division is this division algorithm, that P of x equals D of x times Q of x plus R of x. Which really, when you say that out loud, it just sounds like a lot of x's, right? It's kind of hard to understand. So when they're talking about P of x, they're talking about the dividend. The dividend is going to be what is underneath your division bar there. And then it equals the divisor multiplied by the quotient plus the remainder. So the divisor is what you're dividing by. The quotient is what you have on top when you are dividing. And then the remainder is going to be at the end. So we're going to just review long division first with a couple of things. Okay, so the first thing I'm going to do is I'm going to divide 8 by 128. So when you are dividing, you're asking yourself, how many times does 8 go into 12, which is 1 time. And then what do you do with these two numbers? You subtract them. Okay, so when you subtract, you'll get 4. If it doesn't go into 4, you drop down the 8. 8 goes into 48. 6 times. You get 0. 0 is your remainder, which means your solution would just be 16. Okay? So what this is saying is 8 times 16 is going to equal 128, right? Your dividend is going to equal your divisor times your quotient plus your remainder. So let's say we didn't have something it went into evenly. We're going to do 1, 2, 8, 3. So again, it goes into 12 one time. You have the 48, so it goes in there 6 times. Then you bring down the 3. It doesn't go in there, so you have to put a 0. But then your remainder is 3. Do you guys remember how to write this as a mixed number? Okay, yeah, so it'll be 160 and 3 over 8. This is how we are going to write our answers. We're not going to write them using the logarithm, which is where you see this alternate form. So you are going to write all of your answers in this form. Now, when you look at this in the book, it says P of x divided by D of x equals. You're only going to have to write out the quotient plus the remainder over the divisor. Okay, so write that down with me. Okay, so all of your answers will be in the form, the quotient plus the remainder over the divisor. Now when we do polynomials, obviously we'll have like our x terms, so it won't be just a mixed number. We'll actually have an expression. And then for example 1, it says to divide using long division, and then you're writing your solution in alternate form. So if you want to go ahead and set up your division, we will get started. Okay, so you're setting up what you're divided by, but make sure you leave room on the top, right? Because you're going to have to put some stuff on the top. Let's see it. Why did I do that?
It's too late.
Never too late to make things right. All right, now, if some of you have forgotten how to do long division, I tried to write some helpful steps on the side. And just to reiterate what they're talking about in your textbook, this is your P of x, this is your D of x. Okay, so your polynomial and your divisor. So when you are setting that up, again, you need to leave room above. So I have 8x cubed minus 3x squared plus 2x minus 1. This is nice because I have an x cubed, an x squared, an x term, and a constant. I'm not missing anything. If you are missing something, you can put in a what? A 0 as a placeholder.
Split with Chelsea. Oh, will that work? Yeah. Or do you just do your video and then head down there and relieve her?
Perfect.
Thank you so much.
Okay, so I know some of you forgot this because you just had answers and no work, right? So that means you didn't do your long division. So we got to make sure we understand how to do this. There's a couple different ways to think about your first step. I always think about, okay, what would I multiply by x to get 8x cubed? All right, so Nora, what can I multiply by x to get 8x cubed? You can also think of it as division, right? If you do 8x cubed divided by x, what would you be left with?
8x squared.
Yep. Okay, so 8x squared multiplied by x would give you 8x cubed. So I'm going to put that right on top. Okay, now once you do that, you can see in my little helpful step here, it says distribute blank to x plus 2. Whatever you just wrote down, that's what you're going to distribute. So you're going to be multiplying 8x squared by x, which will give you 8x cubed, and then 8x squared by 2, so you're just multiplying 8 times 2, which is positive 16x squared. Now, just like we did in our example with our numbers, the next thing that you do is subtract. The only difference is here we have 2 terms. So if we're subtracting 2 terms, we have to remember to distribute the negative. So sometimes you'll see it like this. You can do the minus, and then I always change the sign and then circle it. But you could also write it as minus and then in parentheses. If you forget your parentheses, though, that is incorrect. Or if some of you just like write the new sign and don't circle it, that's okay. It just has to be mathematically correct. All right, so 8x cubed minus 8x cubed is 0. Negative 3x squared minus 16x squared is 19x squared, yep. And then I'm just going to bring down the rest of it. So plus 2x minus 1. Okay, so now what we're going to do is look at the next one. And we're going to start repeating our steps. So just like I asked myself here, what would you multiply to get? I can do the same thing with this. All right? So, Maddie, what can I multiply by x to get negative 19x squared?
Negative 19x.
Good. Okay, so that's what I can multiply by. So I'm going to put that right here. And then I have to distribute. So negative 19x times x is negative 19x squared. Negative 19 times 2 is negative 38, so this is negative 38x. And then I'm going to switch my sign, so this becomes plus, this becomes plus, and then I can add straight down 40x, bring down the negative 1. All right, and then Nolan, what am I going to do next?
You're going to multiply the quotient by 40.
And really, you're gonna add it to the quotient, right? So you're plus 40.
Oh, yeah.
Yep, and then you're gonna multiply 40 by x, so you'd have 40x plus 80. So 40 times x is 40x. And then I can distribute my negative, so minus and minus. So then I get negative 81. This is gonna be your remainder. Now, this one turned out pretty nicely. It was natural to be able to stop there. What you would ask yourself is what number times x would be negative 81, but you can't do that. So the reason you know when to stop is based on the degree. What's the degree of x plus 2? 1, because it's linear. What's the degree of the constant? 0, right? Okay, so Whenever the degree is less than the divisor is when you stop. So we're just going to make a little note. Okay, you are going to stop when the degree is less than the divisors. And then you are going to write your solution in alternate form. Okay, so negative 81 became our remainder. Okay, so if I'm going to write that in alternate form, I'm going to take my quotient, which is 8x squared minus 19x plus 40. And then, because it's negative, I can put minus here. And then it would be 81 over the divisor, which is x plus 2. Okay, you could also do plus and then put the negative with the 81. That's fine. Okay, but that is going to be your final solution. Okay, questions for me on example 1? All right, for example 2, when we go to set up our long division, I have 6x to the 4th, 2x cubed, and then I have an x. So what term am I missing? The x squared. So our placeholder is going to be 0x squared. Can you guys think about why the placeholder would be helpful for this?
So you don't mess up where you're subtracting.
Okay, you don't want to mess up where you're subtracting, because if you don't have the 0, what would most people subtract together? Subtract.
Yeah, like the x cubed and the x.
Yeah, two non-like terms. Okay, so if you didn't have the x squared there, people would try to add like the negative x to an x squared. So it is helpful, even though it's not a necessity. And then here we have x squared minus 2x plus 2. Okay, so we are dividing this by a trinomial. I don't think you did anything this big in algebra 2. Okay, so I'm going to give you about a minute to start that and see how you do. So go ahead and get started on B. Okay, so Kelly, what did you start by doing with this?
I did 6x squared.
Yep. Okay, good. So if you do 6x squared times x squared, you get 6x to the fourth, which is what you want. So then you'll have negative 12x cubed and then 12x squared. Okay, so if you didn't have that placeholder, these would be lined up together, and then you might accidentally combine those non-like terms. I'm going to show you the other way you could set this up if you guys like setting it up with the minus and then just doing 6x to the fourth minus this. 2 minus a negative is really going to be what? Plus, yeah. So you have 14x cubed. 0 minus 12 is going to be negative 12. And then this is like minus 0, so those are just going to be brought down. All right, and then Nolan, what did you multiply by next after the 6x squared?
14.
Okay, so why did you do 14x? That's right.
Because the 14x, well, it was 14x squared there, but we already had an x going into that,
That.
so we want to cancel out that.
Yep. So when you multiply the 14x by x squared, you get the 14x cubed, and you want those to match. Okay, and then here you'd have the 28x, and then again you can just leave the negative there if you want. Those should cancel. Negative 12 minus a negative is really plus, so you're doing 28 minus 12, which is going to give you 16x squared, and then negative x minus 28 is negative 29x, and then you're just going to drop the 2. And then, Katie, what was the last one that we had to put at the top?
16.
And why did you choose 16? So what happens when you multiply this by 16?
Oh, you got 16x squared.
Yes, okay, so you want those first ones to cancel. And then negative 29 minus a negative is really plus, so you'd have 3x. 2 minus 32 is going to be negative 30. This is going to be my remainder, and I know that I can't go again because the degree of my divisor is what?
Bigger.
It's bigger, right? It's 2. The degree of this is 1, so the degree is less than the degree of divisor. Okay, and then let's see if we wrote this correctly in our alternate form. Okay, so your alternate form is going to be the quotient, which is on the top, so 6x squared plus 14x plus 16, and then because this is positive, it'll be plus 3x minus 30 over the divisor, which is x squared minus 2x plus 2. Double check that you do have the addition there, that you have all that written correctly, okay? All right, and then we are going to go to the back and we're going to talk about the factor theorem. So I'm going to write down the factor theorem and then we are going to annotate it together. Yeah, Joey.
Do we have to, like, factor the 3 out of the remainder?
Nope, you don't have to. Nope. You can just leave it in this normal form. Okay, so I'm going to give you the remainder theorem, and then we are going to talk about what it means. So the remainder theorem tells us if p of x is divided by x minus c, then the remainder is p of c. Makes perfect sense, right? If p of x is divided by x minus c, then the remainder is p of c. You guys got all that? You know what that means? let's start with what is P of X, right? So if you look at like example 2, you can see this is a P of X, this is a P of X. P of X is just going to be a polynomial, okay? So when we're talking about P of X, we are talking about a polynomial. Bless you. Right? So if you have a polynomial that's divided by x minus c, okay, x minus c is just a particular form of a divisor. Okay, so P of x is divided by x minus c. That's a form of a divisor. We're going to talk about what that form is. So c, what does c generally represent? Yeah, constant. So it's the same thing here. It's going to be a constant. Now, notice how it's just x. You see how there's no variable in front of the x? That's because this has to have a leading coefficient of 1. And also, you can see that if it's just x, the degree is also 1. Now, the reason why that is important is because if you're going to use synthetic division, you have to have that form of x minus c. So you can always divide anything with long division. You can't always use synthetic division. Okay? If it's not in this form, x minus c, then you are not going to get the correct answer when you use synthetic division. So this is saying if you take a polynomial and you divide by something of this form, then the remainder is P of C. So I want you to think about what P of C means, right? I've talked about, like before, if you have f of 1. Michael, what does f of 1 mean? If I told you to find f of 1 and gave you an equation that was f of x, what would you do? Yeah, you plug 1 in for x, right? So instead of f, we have p. Instead of 1, we have c. So P of c is going to be what? Think about like your point, right? If you have f of x, what is f of x? What does it mean? Just f of x. X and f of x, what are they to each other? Input and output, right? X is your input, f of x is your output. This is the same thing, right? Except our output is P of c when our input is what? C. Okay, so this is just going to be your output. When you plug in c for x. Okay, that's all it means. Okay, so if you wanted to find the remainder, whatever your c value was, you could plug that into P of x, and that's what it would be. Now, let's go over just some quick examples of this form. We'll write them down in the corner. Okay, so if you have x minus c form, an example of that would be like x minus 1 or x plus 3. Okay, those are two examples. We're going to do two examples of not x minus c form. So something like 2x minus 1 would not be in that form. John M., why would that not be in x minus c form?
Because the leading coefficient is 2 and not 1.
Good, okay, so the leading coefficient is 2 and not 1. And then our other example is x squared plus 1. And then John T., why would that not be in x minus c form?
Because the degree is 2.
Good, okay, so it's x squared instead of x, your degree is 2, not 1. Okay, so when we go to example 2, it says to use synthetic division and the remainder theorem to divide. Okay, and really we are just using certain pieces of the remainder theorem. It's not going to be an integral part of this. But you do have to remember the note, which I already warned you about. You can only use synthetic division when the divisor is in a certain form. Okay, and that form is x minus c, where c is a constant and x has a leading coefficient and degree of 1. And then this also tells us that we are going to write our solution in the alternate form. So for part A, we're given P of x and we're given D of x, which remember is our divisor. So the first thing we have to do when we're setting up synthetic division is figure out what our value is going to be. So to do that, you're going to set D of x equal to 0 and solve. So if I set x minus 3 equal to 0 and solve, I will get x equals 3. That's what I'm going to use as my divisor in synthetic division. Okay, so step 2 is the synthetic division. And I'm going to set it up over here, but I am going to run through what the steps are with you first, just in case we forgot some of those. Okay, so 3 is our divisor. I set mine up like this. I know some of you like box in the 3, and that's fine. Okay, so for synthetic division, the first thing you're going to do is you're going to put your coefficients from P of x. And what do you have to be careful of? Okay, yeah, so taking your negative. What else? Yeah, if there's a term that's missing. Okay, so let's write ourselves a little reminder over down here. Okay, so as a reminder, you need to use your placeholders. So use placeholders for missing terms. And when I say missing terms, I mean terms that are in between given terms and the constant. It's normally the constants that are the most difficult to remember. So use placeholders for missing terms and constants, or really including constants because they're still a term. Okay, so let's check to see if I have any missing terms. So I have x cubed, x squared, x, and then my constant. So am I good for this one?
Yes.
Yes. Okay, so I'm going to have 5, negative 2, 1, negative 10. Okay, so after you have your setup, you are always going to drop the first coefficient. I'm just going to call it coef. Okay, and then I'm just going to write down what we're going to do, which is multiply by divisor. Step 4, you're going to add the columns. And then you're just going to repeat that process. So the first time I'll go over it just a little bit slower in case we forgot some things. And really I'll have you guys do it with me. So you drop the 5. You're going to do 5 times 3, which is 15. So that's going to go in the next open space. And then you're going to add straight down. So negative 2 plus 15 is?
13.
Say it with me. Okay, so then 13 times 3 is?
39.
Are you guys with me?
30.
Okay, and then you're going to add straight down to get?
40.
40. Okay, 40 times 3 is?
120.
Yep. 120 minus 10?
110.
110. So I always circle the last one. That's your remainder. And then I work my way backwards. So if this is the remainder, this is the constant term, which I just say is my number. And then what comes before the number term? The x term. And before x would be x squared. Okay, and I do that so that I can write my answer in the proper form. So when you're writing this in alternate form, you're going to have 5x squared plus 13x plus 40 plus 110, and this goes over your d of x, which is x minus 3. So not just 3, but the x minus 3. Okay, and then if we wanted to use their remainder theorem to check that our remainder is correct, you could just plug in 3 into your equation. And if you did 3 cubed, 27 times 5, minus 2 times 9, plus 3 minus 10, you should get 110. All right, so for B, let's go ahead and set that up. Notice the difference. So in A, they gave you d of x. Here they just give you c, right? So if c is equal to negative 5, we already know what our divisor is, but we might want to figure out what our factor is. So we know that we're going to be using negative 5 when we set up our synthetic division. But if I have any kind of remainder, I do want to know what my d of x value is. Corbin, what are my coefficients going to be at the top?
4, 0, and -3.
Good. And why do we have to put a 0 in?
For the x value.
Good, for the x value. So I have x squared, don't have an x, so it's 0, and then I have negative 3. So I'm going to drop down the 4. And then see if you guys can do that. Because it really should be very quick, right? 4 times negative 5 is? Negative 20. So when you add straight down, you get negative 20. Negative 20 times negative 5 is? 100. 100 minus 3 is? 97. Okay, so that one should go really quick. Now I do have a remainder. So when you are writing this out, this is your c value. Remember, your form is x minus c. So if I have x minus negative 5, my divisor is x plus 5. So that's your d of x. Okay, so really, now that we can see where this is coming from, we know it's just going to be the opposite. If it's negative 5, it'll be x plus 5. If it was 5, it would be x minus 5. Okay, and it comes from this form, your x minus c. All right, so then let's write our final answer. So this was my remainder, which means this is my number. This is my x term. So I have 4x minus 20 plus 97 over my divisor, which is x plus 5. Okay, questions for me on those two? All right, for example 3, it says use synthetic division and the remainder theorem to evaluate p of 1/2 for p of x. Now, notice how the directions are different from example 2. Okay, so here it just said you were using it to divide, and then your answer was written in alternate form. This doesn't say we're dividing, it says that we're doing what? Evaluating. If you're evaluating something, what does your answer generally look like? some kind of number, right? Some kind of value. So we are going to be using the remainder theorem a little closer here. So when we're evaluating p of 1/2, that means your c value is what?
1%.
It'll just be 1/2. Okay, so just like this is p of c, right? This is your p of c. So your c value is going to be 1/2. And then you're going to use that to do your synthetic division. Okay, so you will have some fractions when you're doing synthetic division. Nothing to be scared of. So set up your coefficients. Okay, so CJ, will you go over your coefficients with me?
Yeah. We have 2,
Yep, so that's for x to the 4th.
-3.
And
No. Oh,
what are
it's
we
0.
missing? Yeah, good.
zero.
Okay, yep, so 0 for x cubed. And then your -3 for x squared. Okay,
And 3/4.
okay,
And then 0 again.
good. Did you guys remember this? Did you guys remember your 0 at the end? Because that's for the constant term. Okay, so if it starts with x to the 4th, you should have your coefficients for x to the 4th, x cubed, x squared, x, and then your constant. Now, when you're going through this, multiplying by 1/2 is just like doing what? Dividing by 2. Okay, so these are things you're going to have to do without a calculator. 2 divided by 2 is 1. I'll use the other color. Okay, 0 plus 1 is 1. 1 times 1/2 is 1/2. Now, -3 plus 1/2 is what is a mixed number? Yes, -2 and 1/2, which how could we write -2 and a half as a improper fraction? Good, -5/2. Remember, 2 times 2 is 4, 4 plus 1 is 5. So now I'm going to multiply this by 1/2. So -5 times 1 is -5. 2 times 2 is 4. So you do have to remember how you're going to multiply and add fractions together. This one actually turned out very nicely, because see how I already have the common denominator? So I'd have -2/4, which reduces to -1/2. And then I'm going to do -1/2 times 1/2, which is -1/4. And then so when I add those together, I have -1/4. Now, remember what I told you before. The remainder theorem tells us that if you're dividing by x minus c, your remainder is p of c. Okay, so your remainder is p of c. Isn't that what we evaluated, p of c? So this is always going to be equal to what? Well, p of 1/2 is going to be equal to -1/4. How could I generalize that, though? How could I generalize for p of 1/2? P of 1/2 is what? Come on, guys. I mean, I have it written right above it. P of 1/2 is what? P of c. Okay, it's going to be your p of any constant term. We just got done talking about what -1/4 is. What is -1/4 in this problem? The remainder. Okay, so your p of c is going to equal the remainder. So anytime you're evaluating here, your final answer is just going to be your remainder. Okay, now it says use synthetic division. That's why we were going over it that way. How else could I verify that p of 1/2 is equal to -1/4? You could just plug it in, right? You plugged in 1/2 here, 1/2 here, 1/2 here, you should get the same thing. All right, so the next theorem we're going to talk about is the factor theorem. So again, I'm going to write it down and then we're going to annotate it together. All right, so your factor theorem says C is a zero of P of X if and only if X minus C is a factor of P of X. Okay, so C is a zero of P of X if and only if X minus C is a factor of P of X. So if you think back to what we were doing yesterday, that makes sense. Remember for bell work yesterday, I gave you the zeros and you wrote the equation. So if your 0 was -2, what was your factor? X plus 2. If you had -1, it was X plus 1. If it was 0, it was just X. Okay, so this follows along with that. We also need to make just another notation on this. So our note is going to be if X minus C is a factor of P of X, then you will get a remainder of, we're going to leave that blank, when you divide. Okay, so I want you to think about that, right? It's a factor. If something's a factor of a number, what does that mean? It goes into it evenly, right? So like what we did earlier, 12 went in, or 8 went into 128 evenly because it's a factor. What was the remainder of that? 0. Okay, so anytime it's a factor, the remainder should be what? 0. And you will get a remainder of 0 when you divide. If your remainder is not 0, it's not a factor. It doesn't go into it evenly. So, for example 4, when you're using the factor theorem to show that X minus C is a factor for the given values, you are going to use synthetic division, and you are going to basically check if the remainder is what? 0. Okay, so if it's a factor, the remainder will equal 0. Now it says to show that. So if it does say to show that, you are confirming, whereas sometimes it might say to determine if it is. So you might have to say yes or no. With this, it says show it, which means your work is your solution. So for this, they give you your C value of 3. So if they give you the C value, you don't have to solve. You can just go ahead and use 3. And then let's do our coefficients. So I have x cubed, which is 1. X squared would be -1. X is -11. Then I have 15, so I don't need any placeholders. All right, so then 1 times 3 is 3. 3 minus 1 is 2. 2 times 3 is 6. 6 minus 11 is -5. -5 times 3 is -15. Then you have 0. That's your remainder. Okay, so then we would just say, since the remainder is equal to 0, x minus 3 is a factor. Okay, you can also just write x minus 3 is a factor. I want you to understand it's because r is equal to 0. I mean on your homework you can write x minus 3 is a factor. I want you to write since r equals 0 here. For part B, you are given 2 C values. So we're going to do 2 separate synthetic divisions. And then we have to add another note in here. So whenever you're writing down your factors, you need to have integer coefficients. Okay, so we'll put a note here. All factors need integer coefficients. What's an integer? Yeah, a positive or negative whole number. Okay, so it says all factors need integer coefficients. Okay, so for part B, let's do the 1/3. So if C is 1/3, again, remember it's like you're dividing by 3. So I have 3, -1, -21 for x squared, -11 for x, and then 6. So I'm good with my placeholders. Okay, so this is just like you're dividing by 3. 3 divided by 3 is 1. -1 plus 1 is 0. 0 times anything, 0. So when I add, -21. It's working out so nicely so far. -21 divided by 3, -7, -7 and -11, -18. -18 divided by 3, -6. See, that fraction wasn't so bad at all. Now, if you were to write out a factor, right, I know some of you are thinking x minus 1/3. Is 1/3 an integer? No. Do any of you have ideas on how to do it? Yeah, right? So basically what you're going to do is just multiply by the denominator. So what's the denominator of 1/3? 3. So if you multiplied 3 by x minus 1/3, you would get 3x minus 1. That's going to be your factor. If you set 3x minus 1 equal to 0, would you get 1/3? Yes. Okay, so since your remainder is 0, 3x minus 1 is a factor. Okay, and then you also have -2. So your coefficients are the same. So 3 times -2 is -6. Add down to get -7. Then you have 14. I like to count up. So -7 here, which would be 14, which would give you 3, which would give you -6. So if you have -2, since r is equal to 0, what's going to be my factor? X plus 2. So x plus 2 is a factor. Okay, so in general terms, if the remainder is 0, x minus c is a factor. Okay, and you can just use that as your template, right? If the remainder equals 0, your x minus c is going to be a factor. For your homework, I want you to write all of your solutions for the long division in alternate form. So for 3.3, you're doing 3 through 6, 19 through 24, 53 through 56. And then I just said to write solutions in alternate form. when you're using long or synthetic division. Okay? So, with that being said, though, you understand that for example 3, your answer is a remainder, so you're not writing this in alternate form. Okay? So it's only where they're requiring you to write out that solution. And then your quiz is 1 week from today, and it'll be over sections 3.1 through 3.4.